All right, now that we have some basic terminology and conventions down, let's go ahead and get into some examples, do a couple practice problems here, like you might see in your homework. It says, in a debate club, there are 12 boys and 15 girls. So part A, in how many ways can a boy and a girl be selected to represent the club at a meeting? Okay, so we are setting this parameter that there has to be a boy and a girl. So we can't have two boys, we can't have two girls. So how many different ways could I randomly select one boy, right? Well, there's 12 ways to draw a boy, to select a boy. And there are 15 ways to select a girl. And so the counting principle says we would just multiply 12 possible boys times 15 possible girls, and we would get 180 possible pairs of a boy and a girl, right? So 180 possible pairs. And that's a real simple, straightforward application of the counting principle. 12 boys, 15 girls means 180 possible pairs of the two. Part B asks, are the selection of a boy and a girl dependent or independent events? So the boys are all sitting over on one side of the room, and the girls are on the other side of the room, and I say I'm going to pick a girl and a boy. So once I pick the boy, has that changed anything about the girl that I might pick? Okay, that is to say, does having picked a boy change the probability of any particular girl getting picked? And the answer would be no, right? I pick a boy from a totally separate group from which I pick the girl, and so picking one of the boys out does not have any impact on the group of girls, so this would be an example of independent events, right? Once I've picked the boy, it doesn't change anything about the probabilities of picking the girl. Okay, so these would be independent events. Let's look at another example. The skating club is holding its annual competition at which a gold, a silver, and a bronze medal are awarded. In how many different ways can the medals be awarded if 12 skaters are participating in the competition? Okay, so there's 12 people skating in this competition, right? So one of them is going to win a gold medal. Okay, whoever comes in first, you're standing at the finish line. The one person is going to cross the finish line first, and you're going to have, the question is, how many people are available to cross the finish line first? Before anybody crosses the line, there's still 12 people in the race. So there's 12 different people that might finish the race first. And it doesn't say it's a race, but if it's a race or if it's like figure skating, the same concept applies, right? There's 12 people available to win the first prize. But once the first prize is given, then that changes how many people are available to win the silver. Nobody's allowed to win multiple medals. If that's not obvious, you should know. In a competition like this, first, second, third don't go to the same person. They have to go to different people. So once gold has been given out, there's only 11 people left to win the silver. And by the same logic, once the silver is given out, the silver and the gold have both been given out. That leaves only 10 people left to win the bronze. Okay, so we have 12 times 11 times 10 is 110 times 12, which is going to be 1,320. 1,320 possible outcomes here. Okay, with just 12 people racing or competing in this skating competition, there is 1,320 different possible outcomes for the first, second, and third prize in this competition. Next question is part B again. Are the awarding of medals dependent or independent events? So here we said once we award the gold, that changes how many people are available to win the silver. So if some guy named Jeff is in the competition, if Jeff wins the gold, he is now out of the group of people that could win the silver. So that who could win the silver depends on who does win the gold. So these would be an example of dependent events, because whoever wins the gold can no longer win the silver and can no longer win the bronze, right? Whoever wins the silver or bronze depends on who has won the gold and silver already. Okay. So what we see in this, counting principle shows us that with only a relatively small number of items, we can end up creating a lot of different possibilities for different things that can happen. So, like one example I like to talk about, like if you were coaching a baseball team and you had 9 players who are going to be in your starting lineup, and we'll ignore the DH, and say the pitcher's pitching or hitting, right? So you had 9 players who are going to be in the starting lineup. How many different lineups can you be? Not even counting the people who are on the bench. We're just saying, of the 9 starters, how many different ways could you write the lineup? Well, you would have 9 people available to lead off, but once you put somebody in the leadoff spot, you've got 8 people available for the second spot, and once you've got 8 people in the second spot, or once you fill the second spot, you've got 7 people left for the third spot, and so forth, right? Until you've put everybody in the lineup except for the last person. And so this would be all the different ways that you could arrange the lineup. Once you pick the starters, this is the different ways that you could write the lineup. And if we type that into a calculator real quick, we get 3,628,800, excuse me, said that wrong. 362,880. Right, so just having 9 people in the lineup, you've got 363,000 different ways of arranging them. Sorry, I wrote that wrong. It is thousands, not millions. Okay, so the point here I'm just getting at is even with a relatively small number of subjects or things in play here, you can get huge numbers of different possibilities, right? If I just added, if I add a 10th player in who's going to DH, or maybe you're going to, whatever it is, whatever 10th player, sometimes like Little League has 10 players on the field, you get up into 3 million different outcomes, right? Almost 4 million different outcomes. So you see that numbers can add up really, really fast when you start using the counting principle. Okay. All right. But anyhow, you're going to practice a bunch of that on the homework tonight. I would encourage you, please, to make note of the questions that you have so that we can go over them in class. The examples that we just did were all relatively simple, if I'm being honest. So some of the homework ones might trip you up a little bit. Please make notes and be ready to ask those questions when we meet on Monday.